So this is called the membrane potential. We saw minus 70. Okay, so that's the resting membrane potential. And as things start to change, it's going to climb up to almost here. Okay, to positive 30 millivolt. That's when all the ions exchange, and then it will cause an action potential. Resting membrane potential. Here again, minus 70. Okay, as sodium rushes in, it becomes more and more positive. Depolarization means it will fire. Okay, later on, potassium will start leaving, and it's called repolarizing. Okay, so let's read this. When the cell is not stimulated, all the ion channels are closed except the leak one. It leaks once in a while. Sodium is 10 times more on the outside. Potassium is more on the inside. The inner membrane has a negative protein. Cytosol has sulfate and phosphate that are all negatively charged and associated with the inside, approximately minus 70. Right? So the electrical signal, called action potential. So the resting potential would remain and nothing would happen unless there is some change in the potential. So here's the change, right? Sodium is the key. Channel is open for sodium. It opens. Concentration gradient drive this positive ion into the cells. So remember, the outside is got more sodium. Obviously, when something opens up, it's going to rush in. Okay, the voltage will change to more positive or less negative, or more positive, and it's called depolarization. There's so much sodium in them that the membrane inside actually becomes positive, about positive 30 millivolt. So then what happens? With the positive change, this caused the potassium channel to open. This is the second gate. Okay, potassium is positive, and it starts to leave the cells. Okay, when the positive leaves, what happened? It will become more negative, resulting in negative charge at the membrane, and this is called repolarization. Okay. What started all this channel to open? Remember, it could be mechanical, it could be thermal receptor. Okay. Threshold, think about it as the minimum. For example, something touches you so little, you don't even know. Like a spider walking on you sometime at night, you don't even know that they're walking on you. Okay? And because it did not reach the threshold. Okay? So this is saying if it's not enough change to occur, nothing's gonna happen. Like here it is, not enough to not even enough to get to zero. Okay, nothing's gonna happen. Does not fire. If enough of the change potential, it will reach the threshold. Okay, and it will fire. Now, action potential, remember this, it is all or none. Okay, if the threshold voltage change is reached, charges reversal will occur at the action potential. The action potential will be generated. Okay, action potential will be the same magnitude, always amount. It will be the same magnitude always, amount of charge difference. Okay, so if you have a stronger stimuli, it will increase the frequency, but not the positive 30, minus 70. Okay, but you have a lot more. Okay, so here's that threshold. Have to reach that threshold for a action potential to happen. let's see. Refractory period. Okay. Refractory period is when another action potential cannot happen. It's kind of like a rest. So another one cannot start. Okay. So here's what it looks like. Sodium comes in. It's the action potential goes this way. Okay. And then as it goes through, more channels are open. Okay. Going through here, other channels are open, and so on and so forth. And it moves down the entire axon, just like that. So here we can see when an axon is myelinated, the speed increases. So myelin is an insulator, has a lot of lipid, a lot of fat. Okay. In myelinated axon, there are gaps in the sheath. We saw the gaps right here. Okay. Remember what they're called? Node of Ranvier. Okay. And action potential jumps from a node to a node. Okay. So it's called saltatory conduction. So it jumps. Okay. Saltatory means jump. Okay. Jump. Okay. Action potential does not have to travel the entire length of the cell membrane. So it doesn't have to go from here. It jumps. Okay. Makes the connection much faster. So again, how do we start the action potential? Change in the environment detected by sensors. Action of one or more neuron to another neuron. So it could be electrical or chemical connection. Graded potential. Graded potential is a local change. Local change in the membrane potential. Okay? Just a local change. This could be, think of warm water versus hot. Okay, just a little local change. Two sources of type. If sodium and calcium enter the cell, it will depolarize. Okay, we remember that. Okay, because they're positive. Occur since they are higher on the outside. If potassium leaves or chloride enter, so chloride is negative, the inside become more negative. Okay. Types of graded potentials. Post-synaptic potentials are formed in receiving neurons. Either get excitatory post-synaptic potential or inhibitory post-synaptic potential. All it means is, so the post means after the synapses. Synapses is when they're connected. Okay, two things will happen. Excitatory, that means it's going to go on. Okay, inhibitory is not going to go on. Okay, so right here we can see inhibitory in red, excitatory in green. Okay, so you get a little bit of excitatory, you think you're going to reach the threshold, and then nothing happens. Okay, this is called summation. Okay, where everything is combined, and then a threshold will happen. The cell body may receive both, and the sum of the excitatory, postsynaptic, and the inhibitory will decide whether you will have an action potential or not. Oh, here it is. Synapsis happens in two ways. Electrical, where the ions are passed from one cell to the next. Okay. Or chemical. We saw chemical already using neurotransmitter, mainly acetylcholine. Okay, we saw, remember there's a cleft there, a synaptic cleft. All it has to travel through there. And we saw the action potential comes in. Okay, it arrives at the presynaptic. This is the presynaptic cleft. Here's the synaptic cleft, and then this is the post. So here's the pre. It will release neurotransmitter, okay, acetylcholine, go over the cleft, and then it will attach to the receptor. Okay, whatever is not used up, it will be reabsorbed or degraded. Okay. You don't have to know this chart. Now here is a very complicated one. Okay, so the neurotransmitter comes in, channels open, and it actually activate another. Okay, the G protein activate and bind to the effector of the protein. The second messenger produce and activate another enzyme to open another channel. Okay, so this is, we don't have to know this, but this is how complicated part of the body is. Okay, so that would be the nerve, just the anatomy of the nerves and action potential. Please know the how an action potential happened, the anatomy of the nerve, you know, the axon, the node of Ranvier. These are the nodes of Ranvier. And the minus 70 and the 30, the plus 30, and the threshold minus 55. Okay, remember action potential is all or none. Okay, all right, I will see you for chapter 13.